Now let's look at this particular circuit, all right? And here we have multiple batteries and we have multiple resistors and we have 3 loops as we had before, and we cannot just use the rules of series and parallel circuits to break down this circuit. So we actually have to apply Kirchhoff's rules for this circuit, all right? So arbitrarily, as I said before, let's just define current I1 as moving through this middle branch, and I2 as moving this way from this battery, and they meet up at this branch to create I3. All right. So for my junction rule, there are my 3 currents, I1 and I2 add up to create I3. So in equation form, this would be I3 is equal to I1 plus I2. And now, if we have to pick 2 loops, and let's pick this loop, okay? And if we pick that loop, what we will find is we have 3 circuit elements, right? We have 3 circuit elements, this battery, this resistor, and this resistor. And if I started this battery, as I see, I'm going to traverse the battery from the negative terminal to the positive terminal. And so that is going to be an increase in voltage. So this is going to be 10 volts. And then I traverse this resistor in the direction of I1. So this is going to be minus 6I1. And then I traverse this resistor in the direction of its current as well. So this is going to be minus 2I3. And all of that will add up to 0. And for the last equation, let's just use this top loop right here. So if I start at my 4 ohm resistor, I see that I2 is going to be running from this branch. So at this point, I3 splits up into I1 and I2. So I2 is the current flowing through this resistor. So this is going to be minus 4I2. All right? And again, it's minus because I2 is flowing in this direction. So if I start at this element and I go clockwise, then that is going to be a drop. All right? Then I come to this battery, and if I go clockwise around the loop and I come to the battery, I go from the positive terminal to the negative terminal. So this is a decrease in voltage. Right? And then I come to this resistor, and I'm traversing the loop opposite the direction of I1. So this is going to be an increase in voltage. And then I come to this battery and I go from the negative terminal to the positive. So this is going to be a drop in voltage. And all of that is going to equal 0. So there are my 3 equations, right? There's my 3 equations. Now, again, here we have I1, and that is really about the only commonalities between these 2 equations, but if we're clever, we may be able to save ourselves some work. So if we insert equation 1 into equation 2, okay, if we insert equation 1 into equation 2, then equation 2 will become 10 volts minus 6I1 minus 2 times I1 plus I2, and all of that must equal 0. And then if I multiply this through, then I'm going to get minus 2I1 minus 2I2, and I can add these up to get 10 volts minus 8I1 minus 2I2 is equal to 0, right? And I'm going to write this back up here. And now I'm going to write equation 3 in a slightly more suggestive form. All right? I'm going to write equation 3 in a slightly more suggestive form. And what I'm going to do is group my voltages out front and then write my the rest of my terms in order of the currents. So I'm going to get negative 24 volts plus 6I1 minus 4I2 all must equal 0. So minus 24 volts plus 6I1 minus 4 all must equal 0. And now I have two equations with two unknowns, right? Now I have two equations with two unknowns. So I can now divide equation 3 by 2. And if I do that, I'm going to get negative 12 plus 3 minus 2. And now I have 2I2 in both equations. So now again, if I multiply 3 through by a negative sign, I can now add equations 2 and 3. And if I add equations 2 and 3, then I'm going to get 22 volts minus 11I1 is equal to 0 because my 2I2 terms cancel out. And so if I solve this for I1, I'm going to find that 11I1 is equal to 22 volts, and therefore I1 is equal to 2 amps. Right? And now that I have this, I can plug this result into either of these equations, okay? And I can solve for I2. So I'm going to write this over here. So what that means is that we've picked the correct direction for the current of I1. I1 is indeed moving this direction through the circuit, all right? And if I plug this into equation 3, 12 volts minus 3 times 2 amps plus 2I2 is equal to 0. 12 volts minus 6 volts, because remember our coefficients have units of ohms, so ohms times amps is volts. 6 volts plus 2I1 equals 0. 6 volts plus 2I1, this is 2. 2I2 is equal to 0. And therefore 2I2 is equal to 6 volts, and I2 negative 6 volts. And I2 is equal to negative 3 amps. All right? So we get negative 3 amps for I2. And now I can use the top relation to find I3, right? So I3 is going to be equal to 2 amps minus 3 amps, and I3 is going to be negative 1.0 amps, okay? So what this means is that we actually picked the wrong direction for I2 and I3. So physically, what's happening is that I3 is actually switched direction this way, and I2 has switched direction to be this way. Okay? And that's not terribly surprising given where the batteries are and their orientation. So in fact, what's happening is that the current is leaving this 14 volt battery, splitting off at this branch, and then adding back up, right? So that is physically what's happening. But again, you can define the direction of your currents however you want. If you get a negative sign, all it means is that your initial pick for your directions was wrong. There's nothing wrong mathematically with it. It doesn't mean you got the wrong answer. It just means you picked the wrong direction initially. So if you get a minus sign, that's perfectly fine. All you need to recognize is that the minus sign means the current was in the wrong direction. So then if you get rid of those negative signs and correct your directions of your currents, you now have a picture of how the circuit is flowing. So that is Kirchhoff's laws. I hope these videos have been helpful to you, and we will see you next time.